So we're going to look at measures of center. One of the things that we always want to know about a data set is, well, what's the one in the middle? What's the kind of the average one, the average Joe, the one that's not extreme on the low side or extreme on the high side, but just kind of in the middle. And if we know the one in the middle and we know that it's in the middle, then we can say, oh, then there's some above that and there's some data values below that, some data values larger, some data values smaller. So we always are interested when we're looking at a numerical data set now we're talking about. And the statistics that we use to describe the middle are the mean, the median, and the mode. There is another one that you'll probably see in a statistics class called the mid-range, but that also is a number that gives you the measure of center. So we're going to define these, and then we're going to go on to the measures of spread or dispersion. You know, not only do we want to know where the middle data value is in a bunch, but we also want to know if they're widely dispersed, if the data value goes from -infinity to infinity, or if they're in a very narrow range, like data values between, say, 35 and 45. So, but we're going to start off with measures of center. And the first one is the mean. This is usually the one that we refer to when we talk about average. Average is usually the mean. This is the arithmetic average. This is the one that you use if you wanted to calculate your average test score. So if we had, and that's what this means here. If you had, say, 3 test scores in here, like 75 and 95 and 83, you know, something like that. If you wanted to know what your average score was, then you would take those 3 data values and add them together and then divide by 3. If there were 4 test scores, you would add up all 4 test scores and divide by 4. And so in this one example, if you're going to use your calculator, be sure that you put all these numbers you're adding together in parentheses, or do the calculation in 2 steps. So that's how it would look. And you can probably guess that it's going to be somewhere in the 80s, 84.3 approximately. Say that your average is a 84% or B. The variable that we're going to use, there's 2 of them, and it really depends on whether you're looking at all of the data that exists in a group. That's called the population mean. And in statistics, we usually use Greek letters, like this one here is mu, like the cat makes. Looks like a U, a script U, but mu. And then this one here is X bar. And both of them basically give you the same formula. It just depends on whether you're taking a small sample of data values from the larger set of data values, or if you're actually, you have the entire data set, the entire population in a data set. So I wouldn't worry too much about the symbols, but I would recognize this one because our calculator gives us this one, X bar, an X with a line over it. And that means average. This means the sum of all the data values divided by the number of data values. Sum of all the data values divided by the number of data values. Capital N is the population size that we usually don't know, the number of individuals, the number of tests, and little n is the sample size. Okay, so that's the mean. For a small data set, it's not too bad to do that. All right, the next measure of center is the median. Okay, so the median, here it is. The median is defined to be the middle data value. So when you have a bunch of data values, you just kind of line them up from smallest data value to largest data value. They have to be ordered in ascending order from smallest to largest. And then you physically just go right into the middle and say, this data value here is in the middle. Now, if you have an odd number of data values like this, you know, something like that, we would say that the sample size is equal to 5 because there's 1, 2, 3, 4, 5 data values. The median would be the one right in the middle, that one right there. So we would say, now it's important, I ordered these for you, but what would be the median of this data set? What is the median? Now, what's important here is that 3 turns out to be the smallest data value, right? And if we wanted to identify the center, the middle one, it makes sense to first order them. So what we would do first is we would order these from smallest to largest. After they're ordered, then we would pick out the middle one. So we take our original unordered set and we sort them in ascending order, and then we pick out the middle one. So in this case, the median would be 6. Now, if you have an even data set, number of data values, something like this, 2, 9, I'll order these as well, 13, 17, and 20. So now we have an even number of data values, 6 of them. The way that we're going to calculate the median here is we don't have an odd number of data values, so we don't have a single one data value that's directly in the middle. So what we do is we go to the middle 2 data values. So we have 3 on this side and 3 on this side. The middle one would be right here. And so what we're going to do is we're going to take the midpoint between those 2 middle data values. What data value, even though it's not in our data set, what data value would be right between 11 and 13? Okay, yeah, so we would say that the median is equal to 12. If the numbers are messier, then we would take the 2 numbers, add them together, and divide by 2. That's the midpoint rule, or that's like taking the average between 2 data values, add them together, divide by 2 to get the one in the middle. So if the number of observations is even, then the median is the mean, arithmetic average, of the middle 2 observations in the data set. And, I'm not going to, focus in on these formulas here, but if the n is 6, then you put 6 over 2, you're going to get 3. And if you put 6 over 2 and then add 1, you're going to get 4. So what they're saying here with these formulas is that the median will be between the 3rd and the 4th data value. 1, 2, 3, 4, halfway between. Okay, you now know how to do the mean and the median. So why don't you fill in this chart? I'll give you a couple of minutes to do that. And then I'll call on you to answer. So here we have a data set. This one here would be, what is the sample size? How many data values are there? This one would be the mean. Calculate the average among those 6 values. And then the median, the middle one. Sample size, 1, 2, 3, 4, 5, 6. We would say n equals 6, n equals 5, and n equals 8. It's important to know the sample size because then you'll know if it's even or odd, and then where to find the median from there. If you add those 6 numbers together and then divide by 6, it's 120, and 120 divided by 6 is 20. So we would say x bar is equal to 20. All right, let me write down the rest of Cece's answers there. And I will let you, looks like she's going with 20 for the median for all of these. And then the median, she's going for 15, 20, and 10. So we have 8 data values. So there is no true middle data value. So what we're going to do is we're going to break it down into the 4 lowest ones here and the 4 upper ones here. Now, 10 and 10 are the same. And so, but you have to arrange them, sort them. And so the median would be right in the middle. It's between the lower 4 and the upper 4, so it's right here. So what we do is we take the 10 and the 10, and we take the midpoint. Well, what number is right between 10 and 10? All right, well, maybe that's not a clear question, but if we take 10 plus 10 and then divide by 2, we will get the 10. This one has a true, the odd one does have a true middle. And this one here, we have to calculate the median by taking the average of those 2. Or just asking yourself, if it's a simple whole numbers like this, what number is right between 10 and 20? And that's 15. What number's between 10 and 10? Well, 10 is the only number between 10 and 10. That could possibly work there. Anything else? Is this clear how these numbers were found? Now with small and nice numbers like whole numbers rounded to 10, we can do these calculations in our head. Anything more complicated, then we're going to use the calculator. And I'll show you how to do that coming up. All right, here's another one. You will be asked to calculate the mean and the median of data that are put in a frequency table like this. So we call this a frequency distribution. So why don't you take a shot at this one? What is the mean and what is the median? Oh, it also asks, what is the sample size? Are you ready? Don't see any answers in the chat yet. Okay, let me just add a little bit more to this. Here's what this means. In this data set, the data value 10 appears twice. These are all ordered. So if I wrote all these data values out, you'd have 2 10s, and then you'd have 5 20s, and then you'd have 10 30s. I think that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and then we have 4 40s, 40, 40, 40, and 40, and then 3 50s, and then 1 60. So if you count all these up, you will see that there are 25 data values. So if I put total down here, then we would have, these are frequencies, so the total number of data values would be the total frequency. So that's the sample size. Now, if you look at all of our data values here, they range from 10s, 20s, 30s, 40s, 50s, up to 60s. And the mean and the median both are looking for a data value somewhere in the center of those. So what data value is in the center? And so probably both of your answers are going to be somewhere in the 30s, close to 30. The median, since there are 25 data values, you have the lowest 12, and then you have the highest 12, and then you have the middle one, right? So 12 plus 12 plus 1 is 25. So it's that middle one, which if you have to have them in order, then you'll take the lowest 12, and then after the lowest 12, the 13th data value would be the middle one. So if we just count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This 30 is in the 13th spot, and that's right in the middle if you have 25 data values. So the median is 30. Okay, see some correct answers in there. All right, the mean is kind of tedious to calculate because you have to add up all 25 of these numbers and then divide by 25. So is it 790? Do they all add up to 790? I saw that somewhere. Okay. So sum of data values equals 790. So the mean equals 790 divided by the number of data values, and that is 31.6. Okay, so I think this is what everybody is telling me here in the chat, 31.6. All right, now might be a good time to get your calculator out, and I'll show you how to do this with the calculator. So the first thing we're going to do is we're going to just maybe try it with this one here. And I just want to calculate, as we did already, you know what the mean and the median are here. So you know that there are 8 data values. You know that the mean is 20, and you know that the median is 10. So when you see a set of data like this, the first thing you're always going to want to do, particularly if it's going to take you some time to add up 25 data values and divide by 25, is to enter the data values into your list. So we've done this on a couple of occasions. You're going to hit the stat key here and then edit. All right, so clear out L1 if you have stuff in there. And now let's enter in these 8 data values here in list 1. Type the first one in and hit enter, second one in, and so on. I have my cursor highlighting the last data value, and you can see that it's in position 8. So I'm pretty confident that I've typed everything in correctly, if that's the case. Scroll through the data values, make sure that they're all correct. Now, once they're in there, you want to, well, there's a couple of ways you can do it. The easiest one is to use one variable statistics, because the single variable statistics gives you all of the summary statistics, including standard deviation and quartiles and some things we're going to see later. The other thing that you can do is to just say, give me the mean of the data in L1. So let me show you how that works. If you hit the stat key, if you hit edit, this is where you enter the data. If you want to calculate things, then you go over to this middle menu. And the middle menu is where we see things like linear regression, some things that we've used before. The one you want is the one variable statistics. There it is there. Now on my calculator, it's an older calculator, so I have to tell it what I want here. And I want the X list to be L1, and I want the frequency list to be blank or equal to 1. There's a frequency on there. So you're going to ask for the maybe the list name. We're going to enter in L1. And if it asks for the frequency, You can either leave it blank or just type in the number 1. And then you're going to want to paste the formula onto the home screen. And when you do, it's going to look like this. And when you hit enter, you're going to focus in on X bar. So X bar is the mean, and X bar is equal to 10. All right, so that command there is in the stat menu, and then you want to go to the calculate menu, and then it's option number 1. So if you go those 3, and then you fill in this menu, and you may have to hit enter a couple of times, this is what the output screen looks like. Notice that it also gives you the 8, the sample size. If I can bring that back up. So we have the sample size is equal to 8. You have the X bar. Oops. Is this the one I did? I must have written this down incorrectly. So the mean here is not 20, it's 10. That's why we use the calculator, right? Because the calculator, we have some, conflict here. It's telling us that the mean is 10. And so we had the wrong answer when we check it. Yeah, if you add all those numbers together, you get 80, and there are 8 of them. So 80 divided by 8. Now, there's an arrow here that indicates that there's more down under. So I'm going to use the arrow keys, and I'm going to go down. And one of the things you see right there is the median. So the calculator calculates all 3 of these, the n, the median, and the mean. You just need to know the variable. Median's not too bad. It's an abbreviation for median, but you need to know also that X bar is the mean, the arithmetic average. Okay, the other thing that you can do is you can use these list functions. So if you want to go to the mean, it's in the list command. Right above stat is list. So you have to hit the second key and then stat. And then there's some operations over here in the math menu. And you can see that one of them is the mean. So if I type the number 3 here and then L1, I'm asking, because I put my data in L1, I'm saying, what is the mean of all the data in L1? And it gives me 10. So for this one, you want to go to second and then stat, and together, those give you the list command. So now you're in the list menu. And then after that, you want to go over to the math menu and then select option 3 for the mean. And what goes to the home screen is the word mean. And then you're going to have to type in the list, L1, and then hit enter. Let's do the median. That's number 4. Number 4, if we calculate the median of that L1, that first list, we should get also 10. It does it for us. So we really don't need the calculator if we're working with nice numbers and a small number of data values. But when we're working with messy numbers or if we're working with large data sets, we definitely want to go to the technology. Okay, one other example, and it allows us to deal with a data set where they're giving you a frequency distribution like this. What we're trying to find the mean of are the data values in L1. So we're going to put the data values in L1, but then we're going to put the frequency values in L2. So where I said frequency here, and I just said 1 because each data value in L1 appears with a frequency of 1, we're now going to enter in for the frequency, we're going to enter in L2 here. And then the calculator understands that the data values in L1 occur with frequency L2. All right, so let's take a look at what this would look like. So we need to enter in data. So we're going to hit the stat key, and then we're going to go to edit. And now we have our 2 lists. Let's see if I saved L2 somewhere. All right, so L1, I'm going to put in the 10, 20, 30, 40, 50, and 60. 10, 20, 30, 40, 50, 60. Then I'm going to move over, and now I have to get it right. I have to have the 2 next to the 10, because the 10 occurred with frequency 2. And I'm just going to put all the frequencies in L2, exactly as they appear there. So once the data are in L2 and L1, then we're going to quit out of here, do the second and then the mode key. And you notice it quits right above the mode key. All right, now we're going to go to stat as before, calculate as before, one variable statistics as before. But now we're going to put in L1 as our data list. And then for me, I have to enter a comma. The comma for me is right above the number 7 there. If you have the newer calculator that gives you the menu, it's going to ask for the X list first, and then it's going to ask for the frequency list, and that's where you want to put in L2. But that's it. Then you hit enter. Notice there's our 31.6, calculated it instantly. There's our sample size, 25, and there's 0 indicating that more is down there, and when we go down there, we see that the median is 30. So we found the median is 30, the sample size 25, and we calculated the mean to be 31.6. Generally, the bottom line on this is when you see a set of data, your first step should be to grab your calculator and enter those data values into L1. Or if it appears like this, enter the frequencies in L, or the data values in L1 and the frequencies in L2. It's going to make your life much easier. All right, so one variable stats, we have the X list, or just the list, is L1, and then the frequency is L2, and then you want to paste. On your screen, it'll look like one variable stats, L1, comma L2, and then you'll have to hit some enters, usually just one to do it. All right, we're going to continue to come back to the calculator. Every time we have a new statistics, I'll point out where it is on the calculator. All right, there's some notes here about mode, and I'm not going to say a whole lot about it, but your authors do a pretty good job of summarizing it. The mode is the most frequently occurring data value, the most popular data value, the data value that occurs most often. And so here are a couple of examples. If you have a data set that looks like this, all right, there's just 4 data values here, n would be 4. And there is no data value in this list that appears more often than the other. They all appear exactly one time. We don't have 2 16s or 2 19s, there's one of each. If there is no most popular data value, then we say that there's no mode. So some data sets do not have a mode, just because all the data values occur equal number of times. All right, this one here, notice the data values are 15, 18, 21, 27, and 15. So the data value 15 occurs twice. That's more often than all those other data values. So we have 5 data values here, and 15 occurs twice. So we say that the mode is equal to 15. And this is a scenario where we have just a single mode, one number, one data value. And then we can have more than one mode. We can have 2 modes, or we can have 3 modes, we can have 4 modes, really depends on the data set. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we have a data set of size 9, sample size is 9. And then if you go through, you can see that 9 appears twice, 7 appears once, 17 appears once, 14 appears once, 7 appears twice, and 18 appears twice. 5 and 14 and 7 all appear once. So there is a data value that appears more often than another data value. For example, 7 appears more often than 14. So in this case, we have a mode. But since we have 3 different data values that appear 2 times, we have 3 modes to this one. And so the modes are equal to 7 and 9 and 18. Okay, just quickly go ahead and calculate the mode of each of these data sets by inspection. They're small, numbers are relatively simple to work with. The data value that appears most often. Okay, so for this one, the data value 10 appears twice, and that's more than any of the other data values, so the mode here would be 10. This one down here, we have, well, each data value appears exactly one time. There is no data value that appears more often than another data value. So in this case, we would say no mode. Okay, the last one, we have 3 zeros and we have 3 20s, and we only have 2 10s. So we do have data values that appear more often than other data values. So in this one, we have 2 modes, 0 and 20. 0 appears 3 times, and that's more than 10 appears. And 20 also appears 3 times. So two modes on this one. All right, so here's a summary of these, the measures of central tendency, or the measures of center. We've got the mean, the median, the mode. And the definition, you add up the data values and divide by the number of data values. The median is the middle data value, and the mode is the most frequently occurring data values. But in very large data sets, the mean, median, mode are all about the same place, right in the middle of the data set. All right, we're going to look at these outliers, and we're going to calculate the mean, median, and mode, and various other things. And then we're going to add one extreme data value. If you have one data value or more data values that are much, much larger than all the other data values, or much, much smaller than all the other data values, then we would call it an outlier. Yeah. So yeah, you can have an unlimited number of modes. Let's say that you have a data set in which you have, you know, 2 10s, 2 20s, 2 30s, 2 40s, 2 50s, 2 60s, 2 70s, 2 80s, 2 90s, but one 100. All of those multiples of 10, 10, 20, 30, they all occur 2 times. The 100 appears just once. So in that case, the modes would be 10, 20, 30, 40, 50, 60, 70, 80, and 90. So you can have multiple modes. But if you do have multiple modes, then those multiple modes would occur the same number of times. Like our example, 10 occurred twice, but the 0 and the 20 each occurred 3 times. And if I added 3 more data values, 30, 30, 30, here, 30, 30, 30, then not only would you have 0 that occurs 3 times and 20 that occurs 3 times, but you'd also have the 30 that occurs 3 times, and that occurs more than the 10s. So we would add 30 as another mode. All right, this one down here is important, that usually we want the mean, median, and mode to be an indication of the center. But for small data sets, the mode rarely gives you the center. And so the mode is a lot of times best used to identify the most frequently occurring data value when you're dealing with qualitative data, where the data values are not numerical. Like your first example today, what's the mode? These are qualitative data, because when we ask someone, what is your political affiliation, they're not going to say 17. They're not going to give you a number. They're going to say Democrat, they're going to say Republican, or they're going to say independent. And those are what we call categorical responses or qualitative responses. But we can still calculate the mode here. But the median and the mean don't make any sense, because for the mean, we have to add up all the data values and divide by the number of data values. And it doesn't make sense to add up a bunch of D's and R's and I's. Same thing for the median. We can't sort these data values to pick out the middle one, because we don't know if I comes before D or R. It doesn't make sense. They're names. But we can pick out the mode, which is the most frequently occurring data value. And all you have to do is to look at these frequencies. And you can see that Republican occurs more frequently than any of the other responses. So we would say that the mode is Republican. And that's what this little blurb down here is saying. A lot of times the mode is very useful when we're dealing with qualitative data. But if we have qualitative data, the mean and the median are useless. They tell us nothing. Okay, let's say that you have this problem on your homework and you want to get it done as fast as possible. So give me the mean, the median, and the mode. Go ahead. I'll give you 1 minute. Now I know that some of you are going to be able to answer this in 1 minute. These are 8 students. This is the time that it took to do an online test. Now this student, 128 minutes, slightly over 2 hours. And this student here was very close to an hour number of minutes. So what's the average time that it takes? Okay, so my hope is that the first thing you did was grab your calculator and start entering in these 1, 2, 3, 4, 5, 6, 7, 8 data values into L1. It's always the first step that you want to do. The calculator is very accurate. When you type in the correct numbers, it's going to give you the correct mean, correct sample size, correct median, and as you'll see later, the correct everything else. But this is an example of a data set where the numbers are not nice. And it's hard to add these in your head. It can be done, but it's just tedious, hard. Now later on when we get to the standard deviation, now I know some of you can just put plus signs between all of these, add them all up, and then divide by 8. But you're definitely not going to want to do that when we get to the standard deviation, because it's a very, very tedious calculation. I don't know, is there a mode? 128, 84. Okay, so this is how long it takes you. It could take you, if you know where all the keystrokes are. I'm not seeing any answers yet, so I'm just going to clear out my list and just start entering in these data values into L1. It doesn't take long when there's only 8 of them. Take a quick scroll through the list, make sure that all the data values are correct. 128. quit, calculate the one variable statistics, and there's the mean. So the most of the time that it takes you to do a problem like this is the time that it takes to enter in the data. So you should find, okay, I see some answers in there now. Yes, 93.1. The mode, there is no mode, because I don't think any of these data values appear more than once. They all appear exactly one time. And then the median is equal to 87.9. So you can see that the mean and the median are fairly close. They should be close because they both give us a sense of the middle of the data set, the center. All right, I want to explain these graphs here, but I think it's best to do that if you actually plot some data. And so what I would like you to do, okay, so we know that this one is skewed left. Okay, so the tail's over here to the left, skewed left. And what these graphs here, what they're trying to show you is if you have a skewed distribution, what's the relationship between the median and the mean? And for a bell-shaped distribution like this, the mean and the median are right in the middle at the same spot. So in a bell-shaped distribution, you're going to find that when you calculate the mean and the median, they should be about the same number. You can also see in a skewed right distribution that the mean will be pulled toward the tail. So the mean is going to be closer to the tail than the median. And if you have a left-tailed test, or a left-tailed skewness here, the tail's over to the left, then you can see that in relationship to the median and the mean is closer to the tail. So I'd like you to investigate this by filling out another table, but I'd like you to do a dot plot first so that you can identify, the shape of the distribution. So for example, if you were going to do a dot plot here, just on your graph, indicate 0, 10, 20, 30, 40, and 50, and then put a dot for each one of the data values. 1, 2, 3, 4, 1, 2, 3, 4. There's 5 tens, another one. And then there are 3 20s and 2 30s, a 40, and a 50. And I'm asking you to do a quick sketch of the distribution so that you can describe the shape. So if you see a graph that looks like this, how would you describe it? Skewed left, skewed right, bell-shaped. So the shape here, shape description, skewed right. Okay, do the same thing with the others, but in addition, calculate the sample size, the mean, the median, and the mode. And then we're going to plot the mean, the median, and mode on these graphs, so it will confirm to you the relationship between the position of the mean and the position of the median. So this first one, sample size, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The mean I'll come back to. It looks like the mode is 10. It's the most popular data value. The median in 16 data values, it's somewhere between the 8th and the 9th data value. 8, 9, 8, 9. So right between 10 and 10 is 10. And then the mean, 16 data values. If you add them all up, 10, 20, 30, 40, 50, 100, 200, 60. So it would be 260 divided by 16, 16.25. And then what I want you to observe here is if we plot the mean and the median, all right, so here's the median, and then the mean is 16.25, which would be right in here. You can see if you look at the relationship between the median and the mean, that the mean is going to be closer to the tail. That's what you need to see here. That one outlier really sways the mean to the tail. All right, do these other ones here. If you really don't want to calculate them by hand, I've given you some simpler multiples of 10 to work with here on these data values. But if you want, you can think of these data values as being, the number of hours students work in a week. Some students are full-time students, some students are part-time workers, and you do have some students that work overtime, more than 40 hours in a week. Right? We don't have to have a context, but sometimes it helps. And again, if you just, want to rely on your calculator, that's okay. You just have to enter in all the values. Get the data values in there. The last one's sitting in position 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 data values. That's the sample size. So we're going to go to one variable statistics, stat key, and then calculate, and then one variable statistics to your home screen. The list is L1, and that's really all you need. If you want to put something in for frequency, it would be 1. And then here are the summary statistics for that second list. All right, so the mean is 20, and the median, 10 values, 1, 2, 3, 4, 5. So it's kind of right between the 20 and the 20. So the median is also 20. The mode is also 20. And the shape. Yeah, this is almost perfectly bell-shaped, right? Symmetric. Okay, anybody do this last one? Kayla has 20, 20, 20 for this one. So does Tasha. So does Chris. Veronica. Okay, good. CC. All right, 40 and 50 for the mode. 40 appears 4 times and 50 appears 4 times, and that's more than any of the others. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so we've got a sample size of 14. Half of 14 is 7. So if you go between the 7th and the 8th value, that's where your median is going to be. 1, 2, 3, 4, 5, 6, 7, and then 8. Well, the 7th and the 8th data value is 40. So the median is going to be 40. 40.71. It's certainly in the ballpark because it's closer to these other 40s, right? 30, 50, 80, 150, 200, 300, 390, 470. All right, I'm not confident. I could have added them wrong. 30, 40, 50, 80, 110, 150, 200, 300, 390. Oh, 390 and 80 is 47. Yeah. Oh, okay. So CC divided by 12. All right. It'd be nice to have some confirmation on this. Again, the 30-second approach is the approach where you do stat, edit, and you just start entering in the data values. Okay. So now I'm a little bit more confident because I can see it from the calculator. This one, by the way, is the sum of all the data values. So if you take the sum of all the x's, all the data values, and then you divide by 14. So this number divided by this number would give you the mean. And then finally, the dot plot here, 0, 10, 20, 30, 40, and 50. And we have, this one is going to be skewed the other way. So we have 2 30s and 2 20s, a 10, 1. So clearly this one is skewed to the left. All right, now I'm going to graph the mean and the median. Here, they're both at 20, right in the middle. So both the mean and the median are right in the middle. And that's what they suggested up here. So if you're going to have a symmetric or a bell-shaped distribution, the mean and the median will be right in the middle. If you have a skewed distribution, the mean will always be pulled toward the tail. If you have a skewed left distribution, the mean will be pulled to the left. So it'll appear to the left or less than the median. And over here, here's the tail. The median is pulled toward the tail. So it's going to be to the right of the median in a skewed right distribution. And you can confirm that down here. If you look at the median is 40, but the mean is 33 and some change in here. So the mean is pulled toward the tail. In this case, the tail is to the left. So the mean will be less than the median. All right. So hopefully you can remember this example as you're reviewing some of this other information. It says the mean is significantly smaller than the median if you're skewed left. So here's skewed left. And notice, on a scale like this, the smaller numbers come to the left. And since the mean is to the left of the median, the mean is less than the median. And that's what they're saying here. For a symmetric distribution, the mean and the median are about the same. And the mean is significantly larger than the median in a skewed right distribution. Notice the mean is to the right, so the mean is larger. Okay, again, you're going to get a lot of practice, but every one of these examples is there for a purpose. And so let me just kind of fill this in. And what I want you to focus on now is we have this one value that's extreme. It's different than all the others. It's unusually hard. This is a person that worked 100 hours in 1 week. That's unusual. Values like that we call outliers. They're extremely large or they're extremely small compared to all the other data values. And here's another one. So the idea is what impact does an outlier, this one doesn't have any outliers, but what impact does a single outlier have on those three measures of center? So in the first example, we have no outliers. In the second example, we have the outlier 100. In the third example, we have the outlier 1000. You can have more than one outlier. You can have outliers on the high side and you can have outliers on the low side. So why don't you randomly do one of these? First one, the second one, and third one. Use your calculator and then put it into the chat so I don't have to do all the work here. As before, sample size, just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The mode is the most popular. 2 10s, 4 20s, 2 30s. Okay, so 20 is going to be the mode. The median is halfway in between. Halfway, 10 divided by 2 is 5. So we got to look between the 5th and the 6th data value, 20. So this is our base case. This is the one that doesn't have any outliers. Let's see, 10, 20, 30, 40, 50, 60, 100, 140, and another. Okay, I think this is 20. Okay, not seeing any answers yet. 27.27. I'll round it to 3. All right, so this is an estimate. All right, let's just say these are they. Good, I see some answers there. All right, yep. CC and Kayla both got the mean, same mean that I have. I'm happy with that. All right, now let's compare row by row. You might not notice, but this has 10 data values. This one has 11. I added one single data value to this list. It's the same list, but I added 100. This one, same list as this one, but I just added one more data value, and that was 1,000. If I add one outlier like that, does the mode change? No, all the same. Does the median change if I add one outlier? No, it does not. What changes is the mean. That one data value, since it's the only one that adds up all the data values and divides by the number of data values, if the number that you're adding, that last number, is much larger than the others, it's going to increase the mean quite dramatically. So if you have a data set that has an outlier like this, if you were to describe, let's say, the work hours, right? All of these are somewhere between 0 and 40, no outliers. Clearly, there's one outlier here. And if you know that you have an outlier, you know that it's going to sway the mean. So if you're looking for a measure of center, what would describe the center of this data would still be in the, the 20 range. So we probably would use the median to describe the center of this data set. We also would use the median to describe this data set, because that one outlier really sways the mean. And the mean is not a very good representation of the center of the data set when that happens. So you'll have some problems where you'll be asked, should you use, which measure of center should you use here? All right, let's see if you have made sense of all of this stuff that we've been talking about. This is the cost of biology journals. Frequency over here, number of journals, lots of biology journals. And this is the cost in dollars. And this is for a subscription. And I suspect that this is a subscription for a year. What is the shape? And then what they tell you here, all right, we know that we have 26 journals for 26 biology journals. If you had to count them, you have 6, 13, 3, 2, 1, and 1. You just count all those up, you'll get the 26. The mean is equal to 1846, and the median is equal to 1142. I should have given you this problem and had you match them up. But one of the things that you notice is that 1142 is about, okay, so this is 1,000 here. So 1142 would be about right here. And notice that's the median, and the mean is going to be much further toward the tail. So we have this skewed distribution here, skewed right. And the median is moving toward the tail. So that's a 1142. oops, 1846. So I'll draw it with a different color. 1846 is closer to the 2. So here's the 1846, and that's the mean. So you can see that the mean, even if the mean and the median are very close to one another, as they are in this case, the mean will always move toward the tail. So which one are you going to use in a skewed distribution? Are you going to use the mean, or are you going to use the median? You can see an outlier here. So this is one journal. I'm not sure which biology journal that is, but it looks like it costs over $8,000 a year. I don't know if these can't be yearly costs. It's much too expensive. But when you have an outlier like this, probably the best measure to use is the median, because the mean is really going to be swayed toward the tail. So use the median in the presence of outliers.